Thanks for having me. This is a great event. This is one of the most important foundations for lots of stuff we're working on. I'm really happy to be here, and thanks for the opportunity. So we're spending a lot of our time, investment, technology, product development, is on 3 different key areas that are shaping the future. And LF plays a huge part of that. First one, which is kind of new, is disaggregation. Disaggregation is probably the biggest architectural change that we're going to see for the next 10 years. I'll end with that topic, so let me leave it to that. The second one is hardware modularity standardization. We're spending a lot of time in OCP, and I will tell you a little bit about that. And then where this foundation plays a very key role is all these modern software approaches, starting with the Kubernetes project, CNCF. We have been a huge contributor and engaged for a long time. And the combination of all of those have become very critical, not only in data center architecture and cloud native, but as you'd see, we see it as critical for everything we do in edge and multi-cloud, which is where all the growth is that we see, no matter what customer type it is, enterprise, telco, service provider. The trends that we see in infrastructure, in a way, we used to have most people buy common set of capabilities of IT in major data centers, but now it's starting to stratify towards 2 new sets of capabilities that people are also looking for and investing in. But let me talk about IT and what's happening in it right now. Lots of virtualization of application. People are going for modern databases like SQL, distributed data, data ingestion, management are big. And then, there has been a big change since COVID and working remotely. It showed up a lot in our laptop and client business, as well as in our IT business. But I would say the change has been profound of how you extend the IT environment to the home. And then everything is becoming software-defined across the board. Storage is going to be the biggest transformation to software-defined that we're starting to see evolve significantly now. New area is cloud and edge. So this is the area of multi-cloud. People call it multi-cloud, super cloud. It used to be hybrid cloud, but the reality is that public cloud has matured significantly, and it's a huge source of technology and innovation and services for many customers, and picking and choosing what to use with what cloud. So it's an era of multi-cloud. It's not about, I want to move my workload quickly from one cloud to the next. It's how do I leverage the best of every cloud, and we're enabling customers for that. And edge is now the new phenomena that's expanding. Telco 5G is the biggest user of edge, and I would say it's the biggest enabler by far. We see that significantly. This is where all the innovation of edge is starting. I'm not saying that there isn't innovation in enterprise. It's very high in retail, distributed environment, automated, stores, etc. But the combination of the two are the 2 pillars that are driving tremendous amount of growth in the edge. And edge is not using any of the old legacy technology. A lot of edge deployment is jumping directly into the latest cloud-native distributed architecture. A second area that we see explosive growth and demand, and I'm not going to talk about it here, but I think this community is huge in driving, is AI and high-performance compute. We're looking at the AI-enabled enterprise. AI ops is in every discussion that everybody talks about. And there, it's all about data, where you store data, where you move it, data analytics, cataloging the data, how you ingest it, and how you enable all these data lifecycle management, and from there enabling hypercompute. We announced a whole new set of servers yesterday, completely focused on GPUs and AI-enabled capabilities. And so that's the new area. So edge requires its own designs, form factors, software stacks and solutions, as well as AI and HPC. And at the same time, IT is continuing to evolve and modernize. Those are the trends that we see that are shaping everything. Everything Arpit talked about before, everybody talked about here, is all the key enablers for everything here on this slide. I do want to talk about one thing we announced at OCP, And we're very much collaborating with Intel, but also with all the logos that you see here on driving complete standardization of the hardware into the server level. So 4 areas we're driving is common motherboard, which includes CPU and memory. We're driving common power supplies, very important for supply chain management and being able to speed up deployment. Probably the most exciting is that system connectivity. The same connectivity we talk about with networking is now moved all the way to the CPU and memory level with new capabilities like CXL and things like NVLink from NVIDIA. So connectivity is something we really automate. It's very critical for interaction of CPU, GPU to memory. And then the system management, which when you think about it on the hardware, there's about 17, 18 pieces of software from security to firmware. And all of it is now with this project, which is called DCMHS. We announced that OCP is becoming very much standardized into DCSCM, which is a prior OCP project. Why are we doing all of this? Because there's an explosion of technology. So many different options of CPU, so many different applications for it, from high-end processing to power optimized and energy optimized edge to new capabilities coming up where people build their own CPU. And we want to speed up, as an industry, we want to speed up that deployment. We want to enable more capabilities and be able to accelerate and deal with the changes in an efficient and fast way. So again, this is how I see the standardization in other communities like OCP, very critical to enable innovation in places like LF here and many other forums. The most exciting thing for us is Sonic has moved to Linux Foundation. It was a OCP project, and obviously Microsoft is the champion who drove all of that, Dave and team and everybody who's very close collaborators with us. And I'm really excited that it has matured and gained industry adoption. Coming here to Linux Foundation and gaining some key members at the board, this to me is a profound moment, because now networking, you have a networking OS based on Linux that's highly adopted. There's so many different hardware vendors, so many different capabilities. You can easily get it everywhere. And I can tell you, our customers are using it in so many ways. I mean, it has become an edge platform. It is critical for converged infrastructure. It's critical for scale out, and now we're going to put Sonic on DPUs to enable disaggregation. It is a tool beyond all others, and I'm really looking forward to all the work here in this foundation. So that's why I started with ARPIT, was part of Dell. We have been a huge champion of open networking. We really joined Microsoft in Sonic, and now it's like a full circle back, the baby's back to LF. And I think it's matured enough where it's going to be a huge enabler. This will be as big as Kubernetes over time in terms of opening up networking and enabling a lot of capabilities. Just one more slide here. I'll speed up a little bit. For us, the big thing to enable capabilities like open networking and many of the cloud native is to get all the storage integration into TCP/IP and networking, so that it's no longer, so you can really scale it out, distribute it, put it anywhere. That's probably one of the biggest projects and hardest work, but now we have TCP/IP integrated in everything we do, all our compute and storage products. We made the investment in that. We released a lot of open source for controllers as well as clients to enable that, and I think that's probably going to open up storage into converged infrastructure as well as cloud native and distributed edge in ways we haven't seen before, and it's going to be a huge enabler. Let me end on disaggregation. This is the biggest change in architecture. DPUs, and they come by many names. People call them IPU, DPU, XPU. There's probably 100 names for it. But the fact that you could have smaller cards that have both high performing compute as well as a full switch of networking, having a network switch and a CPU on one card with full programmability and management is a big game changer. It's the biggest change in architecture we've had, I think, for the last 20 years, because we've always had compute, storage, network. Now we have a new element, and this is why we have collaborated with many people here to bring OPI into the Linux Foundation. I think OPI is probably going to be one of the most meaningful. It's going to open up service delivery for the first time in a programmable way into the infrastructure, and it's going to completely disaggregate a lot of components to enable a lot of flexibility. I do have a video I want to end with, so thank you very much. Let me end on that, and thanks for your time.
Prepared for the advanced computing requirements of tomorrow? Is your IT environment ready for real-time analytics or AI inferencing? The PowerEdge XR4000 enables enterprise-class compute at the edge, even for your most demanding workloads, at the point of sale, on the factory floor, or out in the field. For powering the network edge, deploy Enterprise Sonic to deliver edge automation, flexibility, and business continuity. So let's push the limits of what's possible at the edge. Choose edge solutions that empower your store, your factory, or your mission. Dell PowerEdge XR4000 and Enterprise Sonic Distribution by Dell Technologies.